Okay, so Pluto, that icy little dude way out there, used to be a planet. Even though it got kicked out of the Planet Club, it's back in the news since Neil deGrasse Tyson and Miyoku are talking about something crazy. Could Pluto crash into Neptune? They're not just pulling this out of thin air. These guys are saying Pluto might be on a collision course with one of the giants in our star system. How could that happen? What would it even mean? Is this just some weird coincidence? Or is something big gonna happen? Pluto's path around the Sun gets super close to Neptune's, which is why Tyson and Kaku are sweating it. If something shifts a bit, we could see a major planetary crash. Could it even mess with Earth? And how is any of this possible? Let's check out what a Pluto-Neptune smack-up could mean. Pluto, the ex-planet, is still cool, and these new ideas from top scientists show it's closer to Neptune than we thought. Tyson and Kaku are worried about what could happen between these two. It could be a big deal for us. But how? Pluto's trip around the Sun is different from any other planet. It takes 248 Earth years to go around once. We found it in 1930, and it hasn't even finished a single lap yet. Plus, Pluto's path is super stretched out, not like the other planet's circles. And it's tilted at 17 degrees, which makes it even weirder. That tilt and shape make its orbit one of a kind. Here's a fun fact. Pluto crosses Neptune's path for about 20 years each orbit, getting closer to the Sun than Neptune. So why haven't they hit each other? Gravity. People started studying Pluto's orbit fast after we spotted it, trying to figure out why it was so strange. Unlike the flat orbits of other planets, Pluto's is at an angle and oddly shaped. And crossing Neptune's orbit? Confusing. It's amazing how Pluto's orbit stays steady with all its weirdness. Imagine Pluto, Neptune, and the Sun all pulling on each other with gravity. It's like trying to guess where they'll be based on where they are now and how strong their pulls are. For Pluto, it's all about how its orbit, Neptune's, and the Sun's gravity work together. There are some important things to know to understand it all. Pluto and Neptune are in sync. When Pluto crosses Neptune's orbit, it's always at least 90 degrees away, which keeps them from crashing. Also, Pluto moves up and down when it orbits, so when it's closest to Neptune, it's above Neptune's path. That gives them even more room to avoid a crash. The VZK wobble, named after scientists, looks at how stuff in space pulls on each other. This wobble helps explain why Pluto's orbit looks so weird near the Sun. Though Pluto's orbit looks shaky, this wobble helps keep it on track, keeping it from hitting Neptune or flying away. This three-body thing is super important for understanding how gravity changes orbits. It helps us learn about Pluto, our star system, and galaxies. Back in the 80s, computer models showed that Pluto's orbit, while stable, can be a bit wild. Tiny changes can cause big differences over time. But these models also showed that Pluto's orbit has been steady for ages. Later studies helped us figure out how Neptune, Jupiter, and Saturn mess with Pluto's orbit. Neptune and Pluto have a special thing going. For every 2 orbits Pluto makes, Neptune makes 3. This keeps Pluto stable, and Jupiter helps out too with its crazy gravity, along with Saturn. Scientists think Jupiter's gravity is strong enough to keep Pluto's orbit balanced for a long time. It seems like Neptune, Jupiter, and Saturn are teaming up to keep Pluto cruising safely. These weird but important systems help keep our star system in order. Without them, things would be chaotic. Planets could smash into each other or get thrown out. Scientists say understanding Pluto's orbit is key to understanding how it'll interact with Neptune, and gives us a better idea of how our star system works. Pluto's story shows that even shaky orbits can find balance with gravity. We need to keep watching these oddballs to learn about our spot in the universe too. Checking out far-off worlds often shows us how strange space can be, and Pluto's orbit is a prime example. One of the takeaways is that small changes can have big impact, meaning small tweaks to its location or speed can totally change its path. Computer models have been super useful for understanding these models. They use hard equations to mimic how Pluto and other things pull on each other with gravity. By tweaking small things in these models, scientists can see how even small changes can lead to totally different results. Back in the 80s, the models showed something cool about Pluto. Its orbit has things that make it stable, but it can still get wild. With even a tiny starting difference in its location or speed, Where it ends up could be way different. But even with that, Pluto's orbit has lasted for billions of years, meaning there's something solid about it, even if it looks messy. Guessing orbits, crazy ones like Pluto's, is still hard. The unpredictability makes it hard to say what'll happen. Math models are great for understanding and guessing about space, but they also show us what we don't know. The formulas rely a lot on the starting details, and even a small mistake can mess things up. So being super accurate is hard. Pluto shows us that is always changing and reminds us that there's way more to find out. Figuring out how big planets change Pluto's orbit helps us understand our star system. It shows how each planet's presence and spot can really change the directions of the others. Stuff we take for granted as stable, like planet orbits, can change due to small things over time. Pluto's orbit is already unlike any other in the Our system. Its weird path and steep tilt make going around the Sun rare. Even with Neptune, Jupiter, and Saturn keeping it in check, we can't always guess how small changes might affect its path. The tiniest change could snowball into something huge and change the path of Pluto, Neptune, or even Earth. In short, Pluto's orbit is like a dance, where every move is influenced by the pull of planets nearby. However, the dance isn't set in stone. Tyson and Kaku suggest that even if things look stable now, that doesn't mean they will be later. Space is always changing, and stuff we don't fully get yet could cause even the smallest things like Pluto to cut loose from their orbits. While the chances getting hit are slim, the idea that small disturbances could lead to a shift over ages is a crucial lesson. The main point is not for the purpose of predicting immediate disasters, but rather about watching and studying space, especially the outer bits of our star system. Tyson and Kaku stress that it's not just dodging a crash. It's about getting the big picture and how it all works. In science, especially space, nothing is set. Our models change as we learn more, but mathematical simulations have limits. Small errors can cause wildly different results, so there's always a chance. The more we study Pluto, the more we see we don't know about how things act way out in space. That's why people like Tyson and Kaku are so important by pushing us to think past the obvious, and knowing that what looks safe today might not be later. This unpredictability is part of the universe. With all the tools we have, there's still so much we don't understand. Pluto's orbit is one of many space things that don't fit our models. These oddities make us change our understanding of how planets move, how orbits work, and gravity. These discoveries show us how much we need to learn. We don't know everything. That's why we shouldn't stop exploring. The universe surprises us, sometimes with small things that turn into big discoveries. Pluto, once a planet and now a dwarf planet, shows how our understanding changes. Our views change as we get more data, test theories, and challenge the old ones. Beyond a possible crash, understanding Pluto's orbit helps us understand the whole star system. It's a small version of how planets work together and how even small changes in one can affect the whole thing. The balance between Pluto, Neptune, Jupiter, and Saturn is not just about Pluto. It's about the web that holds our star system together. These things could apply to other star systems too. By studying our star system, we can use the ideas on other systems. Each find, like Pluto's orbit, adds to how star systems form and evolve, and maybe how life starts elsewhere. So, why are people like Tyson and Kaku looking at Pluto now after it was made a dwarf planet? Well, Pluto is a symbol of the space mysteries that are still way out there. Its path might seem weird, but that's what makes it cool. We've learned a lot, but reminds us that space is full of strange objects. Tyson sees Pluto's demotion as a good thing. He sees it as science changing. By learning more, we improve our understanding. Both Tyson and Kaku are worried because even if Pluto's orbit is stable now, change is always possible. A crash might not happen, but they're saying we can't ignore the chance that disturbances could create chaos over time. These changes might take ages, but if we're not careful in watching space, we might miss important signs about how the universe works. Pluto's story calls for more space trips. Tyson and Kaku point out that the universe is unknown, and the more we look, the more we see there is to find. Even if a crash isn't coming, it shows the importance of watching the health of our star system. By studying Pluto and its orbit, we can learn about space bodies work together and how a system can change. Space travel isn't just about answers. It's about asking the right questions. One question is whether the universe is safe than we think, or whether small changes can lead to big changes. If we're to get the future of our star system, maybe even the world, we need to watch and study these faraway worlds. Pluto's is about change. It reminds us that science is never still and even the smallest stuff can have an impact, so we should remember that the universe can be surprising.